Hello and welcome to the part 2 of the Internet of Water, CUAHSI and WADE's That's So Meta Metadata Workshop. Thank you for joining us again on this second day. Just a couple of reminders as we move forward. My name is Ashley Ward. I'm the Engagement and Outreach Associate with the Internet of Water. And today we'll have Adil Abdullah, the Program Manager for the Water Data Exchange from the Western States Water Council, and Ryan James, the Data Analyst for WADE, presenting, as well as Kyle Onda, the Data Architect for the Internet of Water. A couple of reminders before we get started. We are recording the webinar. The recording from day 1 and day 2 will be posted on our website along with the slides from day 1 and day 2, and they both will be emailed to all registered participants of the webinar. Also, as you're watching the webinar, if you have administrative questions, please place those questions in the chat box, and one of us will try and get to them and help you out as quickly as possible. However, if you have questions for the panelists, please use the Q&A chat room, and I'll continue to monitor the Q&A during the presentations and can ask questions along the way. If you're one of our friends who are viewing the webinar over WebEx, just use the chat room for both questions for the panelists or administrative questions. This webinar series is part of a series presented by the Internet of Water's peer-to-peer network. The peer-to-peer network is a community of practice for participants to learn from each other and share success stories and lessons learned about their water data modernization efforts in their states and the organizations in which they work. Currently, we have about 100 members across the US with representing more than 30 states. And we would really encourage you to join. The links to do so will be available at the end of the webinar. Also on internetofwater.org under Connect with us. Okay, so without further delay, I want to get started and first ask if there are any follow-up questions from yesterday's webinar. It doesn't look like I see any, and so I'm going to stop sharing my screen, and Adil allow you to get started.
Great, yeah, thank you, Ashley. And if for the audience with us today, if you have questions from yesterday that you want to ask later, you're welcome to do so. I think we should have time later. Let me share the screen. All right, well, I hope everyone can hear me loud and clear. Hello, everyone. It's early afternoon here. And I assume it's late afternoon on the East Coast, and I saw a few folks overseas, so welcome and thank you for joining us today for this webinar on That's So Meta workshop. We're really happy to be here in participating in this webinar, and I'd like to acknowledge the partnership that we've been with the Internet of Water group and CUAHSI. It has been really helpful to us to broaden our perspective at the program here. So as Ashley said, I'm Adil Abdullah, the Program Manager of the Water Data Exchange Program at the Western States Water Council. And we call the program WADE here for short. And Ryan James, my colleague and the data analyst here at the program, will be talking after 15 minutes or so. So first, I'll share a background about the Western States Water Council and WADE, and then I'll talk about the WADE architecture, schema, and vocabulary, and that is the focus of our webinar today. And then Ryan will take over and demo some of the cool stuff that he's been working on to specifically for metadata for water rights and aggregate water use data in the West. And then I'll come back and talk about the next steps that we're looking into working on in the next couple of years. So thank you all for participating in the survey that Lily sent as part of this, the webinar registration. I looked into it and I found that 80% of you said that you're unfamiliar with WADE and the Western States Water Council. And then 60% said that they're either publishing data, water use data generally, or they want to make that data either interoperable or findable for others outside their organization. And then 30% wanted to learn about metadata. So we tried to tailor the presentation to meet your needs here. So first, the Western States Water Council, which is an under the radar organization, was founded in 1965. I joined it in 2017 as an intern, and I've been really happy to be working for them. The council is a government entity that represents the Western 18 states, and it's a policy. It's oriented around adopting policy solutions for water in the West and advocating for them for Congress. One of the key accomplishments of the Western States Water Council was the support for Landsat 8 that was launched in 2013. Back, I think, in 2008 or 9, after the financial recession, many agents, or there was an idea to shut down this Landsat program, but the council rallied in Congress to support this Landsat that provides infrared imagery, which is really now being used to estimate consumptive water use in the West. In 2012, the council members realized that to support sound policy solutions, they needed data for those positions. And so they founded WADE in 2012, and it's basically a platform to share water use data in the West. And so many of you probably are familiar with these data sets here for the National Groundwater Monitoring Network, USGS network, and reclamation, reservoirs and diversions data, and EPA water use data. And CUAHSI provides like a streamlined access to most of this data. But what is missing, at least in the West, is like data about water rights, aggregate water use budgets, and how much water is being used in a watershed, and where the water comes from, and so forth. And site-specific use and withdrawals provided by the member states, and regulatory overlays data that describe the regulations that govern water use. So these 4 data types that are the specialty of WADE, and we'll be talking about their metadata, and hopefully that will help you in understanding what we do. So the 4 motivating questions for our program, at least the technical part of it, are first, we're looking at like answering these generic questions. What are the appropriated water rights in an area sorted by priority date? What are their beneficial uses? And water rights, for those of you who aren't familiar with the water rights system in the West, they govern and administer water use. So you can't use water unless you have a water right that is legally filed and has a specific legal purpose. And then the next question we want to answer is, or provide, is annual water budget data in a watershed over time. And Ryan will show a cool example of this. Next, we would like to also show consumptive, water withdrawals in a specific location. And CUAHSI does provide this data, but this type of data, but it usually comes from the federal government, not from the states themselves, which kind of a little bit of a harder job because each state has its own system. And then basically these constraints of what are the legal purposes or, well, the legal regulations that kind of govern water use in an area. So in the big picture of what we do, we have in this WADE 2.0 architecture, and there was WADE 1.0, I'm not going to talk about it much, that was the distributed system, but here we have a centralized database that we built, and I'll talk about the schema and metadata, which is your interest today. But generally, we work with every single state in the West and with their staff, and we work on harvesting already public data that is shared through different structures and formats. And I intended to put these different shapes here that reflect the different structures that states share their data in. And they also have different terminology. I'll talk about that in a second. So we write, and mainly Ryan and previous interns write scripts to harvest that data here on the left into a consistent format, the template. And I'll talk about these templates in a second too. And then we ingest them using a data loader into a centralized database in Azure. And we worked with an IT contractor that built an application programming interface that provides streamlined access to all this Western 18 states data in a consistent structure and format and terminology. And Ryan will demo his work on the dashboard here in our Shiny. And we're really happy to be working with the Internet of Water group and Kyle Unda and others at USGS to integrate this WADE system into the GConnects project and the Google for water data, which I'm glad that Kyle also will demo after our presentation. We keep track of all this. If you're interested of all this work, it's on our GitHub, and this link is here in the bottom, and the slides will be shared. So you're welcome to visit us and follow our work. So when we talk about metadata, we spent since 2012, like 5-6 years in going back and forth. And I'd like to acknowledge here actually the work that the previous program manager, Sarah Larson, that has done with our member states. She went back and forth between them trying to understand what are the key metadata that you have in your data so we can come up with this generic schema. And for WADE 2.0, we basically it came down to these key metadata items, which are also, we learned from CUAHSI and ODM work. Yesterday was talked about briefly. And so if you think of a water use data in the West specifically, because the East is a little bit different, a water use amount value, it must have a method that describes how it was collected or estimated. It must have like a location or an area, because it could be a polygon for a watershed. And it must have like the organization. This is the who, where, and then the what is the variable, what is being measured here, whether it's like withdrawal or return flow and so forth. Beneficial use, this is like a Western United States term, which is the legal definition of, or the purpose for what the water can be used for. Water allocations, they're also known as water rights. These basically the definition of the legal terms for how the water can be used and so forth. And priority date is like a very critical metadata term here. Time tracking, so the place and the time that the water is being used, and the source of water that is, whether it's surface water, groundwater, fresh or brackish or saline, and so forth. So we worked with USGS water use program to verify all this metadata schema, and these are very simplified ones. And so if you're interested and you're into more, well, you're into the databases, we have the schema online here. Here's the link, and you can visit it once the slides are shared. And so I think the schema here reconciles differences in syntax and semantics. This is a little bit of a jargon, but basically saying that all the data is being shared through a consistent structure, say a table that has the same columns, and then semantics, which I'm going to talk about now. So we identified out of those like few metadata terms you saw, we dug more into them. And so we have 32 metadata terms, and these are less of them, like the more critical ones. Like say irrigation method, customer type for domestic or water supply provider, and so forth, site type and so forth. Each state has its own vocabulary that describes, say, an irrigation method, whether it's the same exact one, but they use slightly different terminology or not. And so one of the prominent terms that we work with, and Ryan will demonstrate, is beneficial use. So we identified 350 metadata different and unique beneficial uses that states have, and we narrowed them down to 22. And these are basically become the WADE controlled vocabulary for beneficial use that you can query and visualize data through. I want to, so these are two more terms here that we also worked with, but these, the bottom two, legal status of the water right and the water right type, these are very tricky ones. We thought that, say, if a state uses the word adjudicated, New Mexico or Wyoming, that they're the same, but we realized, and we were educated by our legal counsel, that the underlying meaning might be different, even if they're the same exact term. So we're still working with our legal committee trying to come up with these controlled terms for legal status of water rights in the West. We have all the controlled vocabularies for WADE, and this is work in progress online under this repository. And thanks to Jeff Horsborough at Utah State University, we adopted this controlled vocabulary system, which is used for CUAHSI as well to share controlled vocabulary. So here's kind of the example of beneficial uses. You can see that we adopted agriculture for all these different unique ones. One of the funny ones that I noticed that Oregon, they keep track of the crop type through the beneficial use, like cranberry. But anyway, they're kind of very, well, they're similar or different, but we're mapping them through one term. So USGS has adopted WADE or recommends WADE as, or its schema as for data transfer guidance for the states to share data from from their data services into USGS. And I'd like to point you to these templates. So what I've shared, the schema and vocabulary can be complex. If you want to see a simple data template, if you want to share data, or if you want to look at what the metadata terms for WADE, if you visit this link here, and Ryan, if you don't mind to share this link with the group in the chat, that will be great. You can download the templates for the 4 data types that we have. We track all the data mappings from the states. Each state has its own folder on GitHub, and we document all the steps. I'm gonna move faster here. So all this has been possible through funding, whether from federal grants or philanthropic grants that support WADE, and we were able to assist our member states in sharing data by bringing them some federal money or grant money. And this is kind of a summary that we brought about $0.6 million to our member states. So why does all this matter, or the WADE program matter? We want to enable kind of the big picture, like to enable regional water use, energy, and planning. And you know, water and energy are dependent. So this data, when it's available on a regional scale, then you can answer interesting questions that weren't possible before. Water transfers and markets, one of the really interesting ones when it comes to water rights in the West. And given that we're over allocated water use, our streams. So this is a very interesting hot topic in the future, or it's already happening now. Improving federal, state, and tribal cooperative federalism. There are critical discussions among these groups, and so data is usually the fact that everyone agrees on. And we're also like working, say, for example, the Colorado River Basin, and having all this data for the same basin from the states they can trust. That's important for transparency and cooperation. And being a graduate student, and I spent a lot of time in grad school, data-driven research and objective science and analysis, that's really important, and WADE should support that. I'd like to switch gear now to Ryan James Ryan, are you there?
Yeah, let's see. Is it easier if I share my screen? That way I can control the presentation?
Yeah, so I stopped sharing. Maybe, Ashley, should we pause for a second if there are questions, or should we just keep going and we handle the
Sure.
questions?
Right now, I don't have any questions in the Q&A, so we can just pause for about 30 seconds and see if one appears. So if you have questions, please feel free to place them in the Q&A.
I get a quick thumbs up that you can see my screen.
I
Yeah.
can't.
Perfect. Thank you.
Okay, well, if a question comes up, place it in the Q&A and I'll be sure to hop in and get your question out there.
All right, and picking off where Otto left off, today I'll talk about an example of what the final product of WADE will look like on the front end, and an example of the type of metadata we would return with this service. I am happy to announce that the front end is being developed. We are in coordination with our IT contractor on the releasing this, and we are prototyping a couple different approaches right now. However, those are just not ready for public use today. Instead, today I'll just give a rundown on what the front end will include and demonstrate a few in-house developed web applications we've been using for proof of concept for our partners in the Internet of Water, and as roadmaps to help us guide in the development of the WADE 2.0 front end. These in-house apps were produced with the R-Shiny environment. They were built upon the data generously provided by the member states, and they represent the ongoing coordination between each state agency and the Western States Water Council. Sadly, these apps are for demonstration use only at this time, so I cannot share them. In addition, when viewing these slides today, it is important I point out that this data is made available publicly in one form or another, and individual state agencies use separate methods to estimate water data. As a result, water use data comparison across state lines at this time is not an exact science. This is one of the underlying motivations behind the development of the WADE system to help provide this kind of service and roadmap and guide for future development of water data. Before drawing any conclusions on making comparisons on water data across state lines, be sure to consult with your local state agency on their chosen method for data creation. And with that out of the way, the first web application I will demonstrate today highlights the first portion of the data we look at, which is the water right information, which is meant to provide a dashboard-like experience for a user to look at water right information across watershed borders and state line information based on a series of simple high-level filters and search parameters. Those search parameters include the beneficial uses Otto alleviated to before, along with recognized priority dates, the water source information, site-specific information for that water right, regulation, boundary information, and a range of mix-max volumetric quantities associated with that right. Some of the use cases we envision an individual would use this kind of dashboard for would be to say, look for all the water rights intended for a fish and wildlife in a given area. What are the state recognized rights for federal water use in a given area? Particularly today, we'll look at those recognizedly used for the Forest Service and the US Army. And taking that one step further, if we wanted to find all those state recognized federal uses that pertain to groundwater sources only. This slide kind of shows an example of the metadata associated with an individual water right that Otto kind of alleviated to. Right now, we return information in a series of tables with the following idea. We return information on organizations responsible for housing the water right information and the owner information on the source of water for the right, indicators on what the water right is measuring, either if it's a withdrawal or consumptive use, the type of method used to determine the water right, if it's calculated or measured, things like that, state recognized intended beneficial use information, site information, point of diversion information, particularly at this time. We are developing point of use structure for our WADE. That is still ongoing. And of course, we return the pertinent water right information with that, which includes the volumetric quantity or flow, owner information, and priority date. On screen now, you are viewing the cumulative of what we have accomplished so far in the WADE 2.0 system. At this moment, we have just over 800,000 individual water rights spread out across 1 million individual sites throughout 10 of our member states. A couple of those are ongoing at this time as we continue to work with our partners and state agencies. And that number continues to grow as we continue to work and progress on this work. Right now, you're looking at an example of what a dashboard would look like for the water rights application data. On screen, you're just in the center of this, you'll see kind of the generated map with those 1 million individual sites. And on the left, you kind of see what would look like to be a series of filters and search tools available for water rights. Going back to that first use case of looking for a water right associated for fish and wildlife or an in-stream flow, we can see here near the bottom that it's a simple search for looking for all water rights associated with those 3 water uses. And in the end, it would return something similar to this, where we can see the water rights returned are fish in purple, the wildlife as red, and all the in-stream flow as the blue. For that second use case, it's a simple matter of changing the dashboard approach of, instead of looking for a beneficial use, we now want to look at who is the associated owner for a water right. In this case, we're filtering down to what are the state recognized rights for federal, US Army in red, and the US Forest Service in green here. And we can see those spots here in the center of the map. And taking that one step further, if we wanted to look at those federally recognized water rights and for groundwater only, the type of metadata we would return would also have that ability, seen here with the green in groundwater, purple for a mixture of surface and groundwater, and then the whole map returned with a different background to help emphasize where those sites would be. This is kind of an example of what would return on the app itself. An example of the tables that would return, I was only able to fit the beneficial uses and sites at this time, but you can see that these information would return in a table format, and from there it's possible to allow the user to export that information, say as a CSV or an X file, whatever was easiest for them. Moving on, I want to talk about the second type of data we work with. The second in-house web app I'll demonstrate today focuses on that annual water budget information across a watershed over time, which we commonly call just the aggregated data, as it's the collective water use over time aggregated into a state-specific area. As an example of a use case I'd like to demonstrate today, if we were looking for the highest annual use in a specific year in a given area. In this case, we'll look at the highest use in Texas in the year 2010. And then for a second use case, if we were to look for a annual water use per beneficial use in the Green River Planning Basin in Wyoming. Similar to water rights, we do collect and return the metadata associated with the aggregated use. Aggregated use does return information instead of a specific site, we return it in a given area, which we call a reporting unit, which instead of the single volumetric entry like the water right, we return a time series of the volume of water for that given area. In addition to the recognizable metadata of the organization, the water source, the method, the variable it's measuring, and the associated beneficial uses. So far, we have collected 6 states worth of information within our WADE 2.0 system. In addition, with some river basin specific information of the upper Colorado provided to us by the Bureau of Reclamation. Each state provides its own approach to aggregating water use over a given area. Water use can be aggregated at a higher level based on shapes such as the county level or hydraulic unit level, In some cases, the states like to take that a step further and they define their own state boundary, their own boundaries where they aggregate water use. This is an image of what the layout for the dashboard would look like or how it would be operated. We can see in the middle here the produced map that shows the given reporting area. In this case, we are looking at the county level aggregation of water use for Utah, New Mexico, and Texas. On the right is the ability to filter through, I apologize, on the left is the ability to filter through different reporting unit types, which includes at this time, county hydrologic unit 8, custom shapes specific to a county, and the provided bureau information given to us. And on the top right would be is an example of the type of tools and search parameters we allow for this kind of thing. Going back to that first use case of looking for the highest water use for Texas, it's a simple matter of just filtering down the available tools to the year 2010, selecting the county units, simplifying that search down to Texas, and in the end, it's just a simple visualization inspection to look at which county had the highest use. In this case, it's the darkest blue, which was Harris in 2010. Going on to that second use case of returning water aggregate use over a given time for beneficial use, it's a simple matter of just swapping to the different reporting unit of interest. In this case, it's the provided bureau information, looking at the Green River Basin in Wyoming, and a simple click from there, queries our WADE 2.0 API, and that returns the line plot of water information per beneficial use in a given area. Here on the bottom left, you can see the returned information. In this case, it looks like it was irrigated agriculture had the highest use over there recorded over the time over any other use. This slide shows those same results just in a different format. But as a pie chart in the year 2009 instead of a line plot, it is intended that we return, that the API return data in a series of different formats that to be as flexible as we can for the user experience.
Hey, Ryan, I have a quick question.
Sure.
Will the data be downloadable from WADE? And if so, in what formats?
Yes, it is. And I'm getting to that. I'll give an example right now. That data does return right now in table format, as you can see on the screen right now. The data eventually will be made public. At this time, it does contain a little sensitive information, and along with the work that Otto and I do is we spend a lot of time quality controlling with the states to make sure that what we're representing is what the states have in their own database and information. I should point out that it is WADE's intention not to replace these existing systems, but only to provide the service of looking at information across state lines and watershed boundaries. As always, make sure to consult your local state agency for the water right information. But to continue, yes, that information will be downloadable once the final product is made released. And that ends my portion of the slides. If you want to take back over, Otto.
Yeah, thank you, Ryan. We're being efficient here on time. So let me get my slides. Okay, let me go. So yes, all this data should be available publicly once we finish our development here and testing. We have to, as Ryan said, we work with every single state, and we document the steps and how we map the data, especially, we want to make sure that the control vocabulary are mapped the correct way. And so yeah, once the states approve that data, hopefully we'll release it. There's no definitive timeline right now, but we're looking into potentially next summer or fall to have a beta release. This data, yes, it will be very helpful for regional scale analysis and data. For a legal, like if someone wants to file a claim about water right or look into a specific water right and what's the purpose of it and all that, that's not the intent necessarily of WADE. And one of the reasons because, as Ryan said, we don't want to replace the state's data sets for that purpose. And data might change faster than we can handle here. we're trying, or I think ideal goal is to have a push or a pull from our member states data sets into WADE twice a year. But as you can imagine, data can change overnight or monthly at the states level. So as far as
we have a quick question. Can I?
Of course. Yep.
Okay. Is the uncertainty associated with the data in different data sets also integrated into the outputs in WADE?
So I'm just seeing I didn't share the screen. So yes, well, maybe yes and no. We document we have the metadata that describe this potential uncertainty in the original data sets, if the states have it. So there are different types of data. Say one of them is like modeled or estimated consumptive use in the West. And there's usually a model that does that for each state. And we try, so we have one clear example is the methods table, where we ask the states to provide what are the specific methods and uncertainty that is associated with them. And we share that. But it's not gonna be like an apple to apple comparisons when it comes to say consumptive water use in the West. There's gonna be some like users need careful attention when they use that data at some point. And we're working with the member states to make sure that when we share the data, we share the disclaimers and the whatever uncertainty related to it. I hope that answers the question.
Thank you. And I just wanted to, are you meaning to share your screen right now? I'm not seeing your screen.
Yeah, and I have 3 screens. I'm trying to find where this, I've done it before. Oh, there it is. Okay.
I can share mine again if you are having difficulty.
Sorry about that. How about now?
Nope, we see it. Perfect.
Okay, perfect. Okay, so didn't miss much, but so the next steps here, we're working. So our current funding is from the Amore Foundation through the Internet of Water Group organization, and it expires like by October next year. So we're working to hopefully secure more funding to continue the program and sustain it. And we're working with our member states. There are different grants. I'm not sure if for those folks who are coming from, I think, well, all the states. The USGS has a program called the Water Use Research Program. It provides grants up to $250,000 per state to help them share data. I mean, mainly water use data with eventually with USGS, but as I said, they're recommending WADE Data Dictionary or the templates that I've shared, or the link is here in the chat to share that data. If you're not aware of it, make sure to check that water grant. So we'll continue to connect more states to WADE. We're working every day on that, but I think hopefully by the end of next year, we should have pretty much all the states data connected, or at least the main data types that we're focusing on. We're going to continue to work with our IT contractor to design the front end of WADE 2.0, and they helped us so much in deploying the database in a cloud setting, secure setting, plus building the API. So we're hoping now they can help us in taking all these dashboards that Ryan, or the apps that Ryan showed into real world like use, where you can literally click at them anywhere. But right now they're not ready yet. We're really happy to be working with Kyle and USGS on the GConnects project. And so I'm excited to see his demo in a bit. And I think hopefully, I don't know if WADE is part of the demo, or at least some of the data that we have here, we shared with Kyle, will show up there. And then, as I said, the beta release, hopefully next summer or fall next year. Stay tuned, and if you're interested, let us know, and we're happy to help you. We are here in phase 2 of the WADE program, the previous program manager started WADE in 2012, as I said, and she established the relationships with our member states. And now we're putting a lot of gasoline on this program by taking it to the next level as far as the technical aspects of it. And hopefully with the phase 3 that we're looking into the next couple of years, we'll focus on serving use cases or trying to answer regional questions to our member states across boundaries like the Colorado River Basin, the Rio Grande, Columbia. Those are like big basins that span many states, and this data should be very helpful to them. We're thankful to our member state agencies, all of them, and to the funding that we received through mainly to start the program, the EPA Exchange Network Grant program, and then many of the foundations up here, the Water Foundation, Mitchell Foundation, and the Moore Foundation. Our IT contractor here, Don't Panic Labs, a cool name, USGS, Internet of Water, we can't thank them enough, and CUAHSI for sure. Thank you all. Here's my email, and here's our web page, and here's my cat. Oh, and here's Ryan's dog, or puppy. So thank you so much.
That's great, Otto. There is one quick question in the Q&A for Ryan and Otto. How can we see the trimmed down vocabulary chosen?
How do we see, what was that?
The trimmed down vocabulary chosen? Oh,
so if you go to vocabulary.westernstateswater.org, .gov, well, .org, sorry, our email is part of the state of Utah, it's .gov, but not. I'll share it with you in the chat here. And it's a work in progress. So let me share it here. So it's not final, and Ryan and I will work on it almost every day. So let us know if you want to use it for anything.
Okay, and Otto, you've placed that link in the chat for those of you who would like to go.
Yeah, it's there. Yeah, and you can download each of those tables and look into them.
Okay, great. And Otto, I think you have a quick poll before we pass over to Kyle.
Oh, thank you so much, for launching that one. Yeah, please, for the audience, if you answer those questions, that would help us. Thanks. Kyle, I'm excited to see your demo. Are you there?
I'm here. Oh, do I just get to start it now?
Well,
no.
Let's get the poll just another minute or so. Folks are still answering the poll. In the interim time, though, if anyone has any questions from yesterday's, we can answer questions both from Otto and Ryan's presentation today or Jared's yesterday on CUAHSI while we wait for the poll to run its course. And Lily, it looks like folks have stopped, so we could probably end the poll. And thank you so much. Kyle, if you want to share your screen, we can move on. We're running a little bit ahead of schedule, but that's okay. That gives us some time and you don't have to plow through so quickly.
Okay, then. Let's pull up this presentation. So are you seeing the screen and not the presenter view?
Yes, perfect, thank you.
So thanks everyone, and thanks to Otto, who's been a really great collaborator with the WADE system. And also to Jared and CUAHSI, who's been a big collaborator with the Internet of Water. So this presentation is about data discovery using kind of a lowercase Internet of Water, which we are actually starting to implement now, this sort of cross-organization, cross data system Internet of Water through this geoconnects.us project, which I've presented on before, maybe to some of the attendees, but it's maturing, and now we have some interactivity to demonstrate. So here we go. So geoconnects.us will be a framework for metadata publishing and metadata harvesting for data discovery. And basically, we want to make the Google for water specific data. We want there to be a user-friendly search engine that allows easy discovery of all water data published by all organizations. And the way this will work is with sort of three basic conceptual concepts. Three conceptual elements. The first being that there should be persistent identifiers unique for every location or feature for which data is published about, or for which data is collected on. Just like there are DOIs for data sets and DOIs for, journal articles, there should be identifiers for places that water data is about. Secondly, these identifiers should resolve or link or direct people to landing pages. Landing pages being human readable, websites on the internet that provide the metadata specific to that location, including where to find the data about that location. And finally, a linked data system, which is essentially a web crawler, very similar to the Google web crawler that builds the Google search index, that can sort of harvest all of the metadata in these landing pages to create a knowledge graph of all water data and how it's linked together spatially or by subject matter. So what we want this system to do is allow users to connect disparate data together across the silos that are created by organizations and disciplines that create water data. So you can imagine many of you may be part of organizations and institutions that collect water data. There are academic organizations, state and federal government, industry group, that all collect data about different aspects of water at different places and publish their metadata in different ways. And right now you can imagine there are many use cases where it would be useful to integrate data from across these silos, but it currently takes a lot of work to even find or even know about other data. And so right now we're sort of in the left part of the situation, and geoconnects.us is a way for people to publish, for these organizations to publish metadata into that can be collated into a single search index. That would allow these silos to break down, because it would allow organizations to know about data relevant to their own data published by other organizations. And we also want, of course, the general public to be able to access this same information. So breaking down how this works, the principal concept here is that there are many data providers that are collecting data on one thing, but may label that thing differently or name it differently, and therefore represent it in its metadata differently. So you can imagine a question: what data is available about this particular stream reach? And there are currently maybe several siloed data sets. The USGS might have a stream gauge there. And it might be indexed to the national hydrography according to the NHD COM ID, which is this 7-digit number. And then maybe the state EPA or DEQ might have data from habitat surveys in the specific watershed that surrounds that COM ID and its neighboring ones. And it might label that data according to the HUC-12, the 12-unit hydrologic digit code. And then there might be some university project with a lot of water quality monitoring stations in that area. But its data set might be labeled with the header watershed, and the name of that watershed being Morgan Creek. And so when we're trying to think about integrating these data as someone from outside this siloed system, or someone who doesn't have detailed knowledge of all three systems, we ask questions like, are these data about the same thing? If not, are they about related things? And if they're related, how would I find them together? And so the GeoConnects framework relies on all these organizations beginning to publish their metadata using unambiguous identifiers for what their data is about. So for example, the USGS could publish metadata saying, this data set is about this URI. So this URL formatted string geoconnects.us/nhd+v2/comid/that number. Similarly, the other organizations might publish metadata saying, not just some column in their data that says HUC-12 and that 12-digit number or that watershed Morgan Creek, but the specific identifier within the GeoConnect system representing that same HUC-12. And then the GeoConnect system would inherently know, based on our indexing, that that COMED ID that the gauge is at is within the HUC-12 identified by that ID. So then when we think about this process going backwards, so what the GeoConnect system will do rather is when organizations link their data to these reference kind of concepts, the system will harvest those links and then know about how to go backwards. So for example, if we ask this question again in a world where GeoConnects is operational, you would just query GeoConnects, what information is available near here? And it would tell you, well, that area, that point is near this COMID. And we know that there's a USGS stream gauge about that COMID. We also know it's within, that COMID is within this HUC-12. And in that HUC-12, there's two data sets linked. And we can direct you there as well. So I noticed there might be a question, which I'm happy to pause for.
Great. And actually, the question is about the presentation slides. So it's probably a good thing for me to remind everybody that the slides and the video will be posted on our website and emailed to all of you who have registered for the website. So for those of you who are wanting to get copies of the slides and the video, they'll be available to you. Sorry, Kyle.
No problem. So now I'm actually going to stop sharing and we can do a brief kind of interactivity. Oh, well, I should keep sharing. I'm sorry. I should keep sharing. I will stop the presentation though. And we can explore some of those reference features that we're starting to encourage people to publish metadata about their data that references them. So if you go to, sorry, info.geoconnects.us, you'll see this page. And these reference features, I'll note, are not really meant for human browsing. They're meant for machine browsing. However, they represent locations on the internet where a web crawler can go and organize metadata from in an automated way. So these are the things that these are the types of features we currently have in as reference features. So we have the hydrologic units, 2, 4, 6, 8, 10. We have the national aquifers. We have the census boundaries from places, so municipalities up through states and counties. We have public water systems, including water system boundaries for where those boundaries are available and are made publicly available by states. And we have gauge location. So this is every location where there is some sort of stream gauge or flood stage monitor or sensor, or ever has been, USGS or state or local or other organization. So to give you an example, we'll go slower. We can click the reference gauges, click browse through the items of reference gauges, and click one of these URI links. And so what we notice here is it's just a point about some location, and its URI starts with geoconnects.us/ref, which is the prefix for our reference gauges, and this number. And then we notice there's a bunch of metadata about this location. So its name, its description, in this case USGS, and this subject of link, which says the data set about this location lives at this URL. The other thing to notice is geoconnects.us, we can click it and we'll be returned to the same place here. This URL is different from this one because this is a persistent identifier, whereas this system might change addresses as technology changes and we serve it with a different URI, or maybe some different organization elects to host these. And so this will be different. But the point is this URI is persistent, like a DOI.
Hey, Kyle, can I ask a quick question?
Sure.
Is GeoConnect similar to the community inventory of EarthCube resources for geosciences interoperability data portal?
Yes and no. They have sort of similar goals, but to my knowledge, there isn't actually another system that's creating persistent reference features on the internet for data sets that are independently published to link to. Anyway, so you can see that it would be linked to, in this case, this USGS page about that. And I can also show a selfie, sorry. So this is a CUAHSI landing page. So this is the kind of landing page that we want that to be part of the system, data needs to be published like. So this is actually a site in the CUAHSI HIS hydroclan system that Jared presented on yesterday, that map-based system to access time series data. So this is the landing page for one of the sites in there. And if we look into the HTML source of that page, we notice this block of code here of type application JSON LD. And this is that schema.org markup. So the context here is basically importing the controlled vocabularies that are used down here. That lets a machine know that when this says description, that it's sort of the abstract or description of the site. And it also codifies how to represent the geometry and its location, and the type of thing that it is, which in this case is a hydrometric station. And you also notice this ID. So it has a persistent identifier from the geoconnects.us system, which if you were to go to, would take you right here, even though the actual website where it's at is this selfie.cuahsi.org. All right. So that's those GeoConnect's reference features. And the reason for them is that it's hard to use. In sort of yesterday, we talked about why it's hard to use data without rich metadata. And it's slow. The point of this day's presentation is that it's slow to integrate data without linked metadata. And so now we're going to go on sort of a guided tour of what using GeoConnects might look like. This would be a human sort of, this is sort of designed to be a human readable tour, whereas in actuality, we envision machines being programmed to do much of the steps we're going to do. And so in this exercise, we're going to try to create information from two published data sets that are on the same topic. These are both data sets that are about public water system boundaries. One of them, the California one, is a pretty rich data set. It has 45 columns. We'll see that its metadata documentation is somewhat poor, and it does not use the GeoConnect system. And on the right, we'll be looking at the North Carolina public water system boundaries, which Duke University and the Internet of Water have helped manage along with NCDEQ, which is a much smaller data set, but has better metadata documentation and uses the GeoConnect system. So the exercise is, as a data analyst, you want to find out the service population size, the poverty rate of the service city, and any water quality regulation violations from many water utilities, so that you can do some analysis about water prices, affordability, and service quality. This is a contrived example, but it demonstrates sort of the kind of thing that the system would enable to automate. So here, I'm going to fill out this table, right? So we're going to try two utilities, the city of Sacramento and the city of Raleigh, answering these 4 questions. Where does the boundary data come from? And then those 3 questions, the service population size, the poverty rate of the city, and were there any drinking water regulation violations? And so first, I'll start with the California data set. Here we go. So if people want to follow along, you can get here quickly by going to geoconnects.us/demo/pws/ca.
Lily has placed those links in the chat for those of you who want to copy and paste.
Great. So I'll move this up here and move this table down here so you can sort of follow along with me. So this is this data set. We can read about it here. It's looks like the water board is verifying the data collecting by this water boundary tool. The service area is downloaded in 2019. And for any questions, we can contact this person. And these are the attributes available. So it looks like there's a couple of dress lines, something called boundary type, the city. Anyway, so let's see how many of these questions we can answer from this data set. This, by the way, is an example of an Esri ArcGIS hub data catalog or metadata catalog that I talked about yesterday. This particular might be slow at this particular time. So I'm just going to download the data as a spreadsheet. Hopefully. it's not. Oh, California Water Board, GeoPortal. That is unfortunate. Aha, here it goes. So, is this it? Here it is. Okay, so it's an Excel spreadsheet. We know we're looking for the city of Sacramento. So I'll just create a quick filter here. Note that there wasn't a really good data dictionary, so I don't really know what any of these headers mean. But name seems like a logical place to start. So that's fine. There's a few examples. We want City of Sacramento, Maine, the main one. All right, so we found it. And then, so questions we have are, where does the boundary data come from? So I'm just gonna look through all the columns real quick. I've done this already, so I know that source detail is probably what we're looking for. And it says ICE downloaded from SACOG 2009 and linked to me. So that's what we have. I don't necessarily know what that means. It looks like I will be emailing that data manager, whether they want to hear from me or not. It's not copying and pasting, but you get the idea. So ICE downloaded, whoops. ICE downloaded from SACOG. We also want to know the service population size. So depopulati underscore seems like a good field to use for that. I don't actually know exactly if that's the right thing, but that's probably good. And then I see some metadata about the address of the utility, its service connections, but probably nothing. It doesn't look like anything about the poverty rate or drinking water regulation violations. So I know I'll have to go to other data systems. So poverty rate in the city that utility serves. I have to know ahead of time probably that the census is a good place to go for that. So I'll go to the census, I'll just Google that and then go to data. That seems logical. I'll search for Sacramento city. I want the city. There we go. And okay, they have the poverty rate, 18.3%. Great. And then were there any drinking water regulation violations in the past 5 years? So I know just ahead of time that the place to go for that is probably the EPA CIDWIS database. But again, I'd have to know that ahead of time. And it says I can either select a geographic area or enter the water system ID number. Back in here, there are a couple things that might be the water system ID number. Actually, I need to have a lot of content knowledge to know that the ID I'm looking for is this PWSID, and that this is it. In that case, this is the correct one. And we're finding Sacramento. There we go. And it says it's population served, 501,334. So it looks like that was the right variable. And doesn't look like any violations, none. So that was a good journey. And it required me to have special knowledge from my background about where to go for this other information. And how to interact with those data systems. So now I'm going to try the North Carolina version. So geoconnects.us/demo/pws/nc. And I find this site, which is, this is a slightly modified version of GeoNode, which I also mentioned yesterday. There's some metadata here. It's got the title, the digital map of North Carolina water service boundaries. The license is a public domain license. Okay, I see some supplemental information pointing me to the process by which the data were generated. I can look at the data dictionary under the attributes. I see it has some fields. It has a GeoConnects ID. That's interesting. It has PWS ID like we had before in California, the EPA ID number. And it has something for owner type, source type, system type, image type. And it has links to another data dictionary, which has the controlled vocabularies, it looks like. So it looks like source type might be anything like this. Service area would be a service area extent. Water lines was the information used was water service lines from an analog map. Okay, so things like that. The type of file that was digitized to create the service area. So shape files, CAD files, just JPEG images. So that's useful. Now in here, I want to find Raleigh. Those of you who don't know North Carolina, Raleigh's in the middle of the state. So I just kind of zoom into the middle here. And there's the Raleigh utility. So if I click on that, I find some, so here's the GeoConnects ID. And here's the PWS ID. So I want to note this here. So even though this is supposedly a standard EPA ID, it looks like North Carolina system is representing it differently. But they do have this GeoConnects ID referencing the reference feature that has that more EPA formatted one. So it looks like the source is that the CWS provided that it's a service area and it was a shape file. So it looks like, you know, the utility provided a shape file. It doesn't look like there's any information about the population, but the GeoConnects ID tells me there might be linked data about this. So I'll go to it. geoconnects.us/ref/pws/nc 0392010. So here we go. And I can look down here and see what kind of information I have. I see the boundary type. It's a water service area specified in provider. The city served is Raleigh. The city served URI appears to be a GeoConnects ID for Raleigh itself. Population served count looks like a bit of metadata has been harvested from something. 603,000. Can put that in. So now I'm interested in the poverty rate of the population of the city. I see the city as a GeoConnects ID, so let's see if there's any linked data about the city here. It just looks like a bunch of weird identifiers, but at the bottom there's something called census profile, so we can go to that. Oh, and that's the same kind of census data system reference point. So we can get that. And then if we go back to Raleigh, how am I going to find drinking water regulation violations? It looks like there's a direct link to the CIDWS page about this utility. So it looks like, oh, they had some sort of monitoring violation about bromate. in 2016 that was resolved. So there was a bromate violation 2016. And another one about heliacetic acids in 2015. All right. So that was a quick walkthrough of, what manually traversing the GeoConnect's knowledge graph might look like. When I timed it doing this myself, even as someone who knows immediately about the census in CITUS, it took me 143 seconds to answer all that data about Sacramento, and not really having a good answer for the provenance of the boundary data. And in Raleigh, I could get all that information in roughly half the time. And so the big justification for this is actually the automation. So if you think about the automating data integration process that you might want to repeat for hundreds of utilities and maybe do that every year, something like that, there are 4 kinds of tasks I would think about. There's kinds of basic tasks that I think can be pretty reliably automated. There's tasks that really require content knowledge about where to find these different information. There's tasks that require both content knowledge and knowledge about how particular data systems work. And then there's tasks that have failure points because there's no good way to automate sort of conflicts where you might return multiple results or conflicting results, something like that. So if I'm thinking about automating this process without GeoConnect's IDs, I know I'm going to have to download the boundary data set. I'm going to have to make sure that that data set has an identifier that can be used in the EPA CITUS system. I can call the EPA EnviroFacts API using that PWSID if I know how to use that API. Then I'll have to download the census place file, probably do some kind of spatial join with the census place data and retrieve the census GeoID. But this can be a problem if there's, there's many cities covered by the utility, which wasn't the case in my specific example. And then you can call the census API to get the poverty information using the GeoID for that place. With the GeoConnect's IDs, I have to download the boundaries. It would have a GeoConnect's ID, so I could just go to all the GeoConnect's ID identified websites. I would have to know that CITUS is what I want, but I could just go there. And then I could get the city served URI linked data, that GeoConnect's ID, and get the census link from that data. So it's in general more automatable in a world where data sets are using common identifiers to reference what they are about. So the main point here is we'd like data providers to reference GeoConnect's IDs in their published metadata, host data as feature level landing pages, like I showed, like the USGS does with stream gauges, or like I showed with that CUAHSI example. And if you like, you can mint GeoConnect's IDs for your own websites or APIs about your own data and allow other people publishing data, maybe with derived data products from your own data, to link back to yours directly. And so geoconnects.us, that website provides guidance on minting IDs. And geoconnects.us/demo provides a graphical and R-based, so a more automated view of how traversing this knowledge graph might work. And with that, I'll stop and see if there's any questions.
Great. Any questions for Kyle, or as a matter of fact, Kyle, Jared, Otter, or Ryan at this time? Again, just a reminder that we will be sending out the slides and the video. You'll receive that in your email, but also we will link to it on our website on the webinar page. I'm going to go ahead and share some of this information with you now. You can contact the Internet of Water at this contact information, visit our website and join the peer-to-peer network. We can also continue this conversation. If you have questions that come up, you can navigate to the Internet of Water's peer-to-peer forum at this address here and post any follow-up questions, and our presenters here will respond in the forum. It looks like there are a couple of questions quickly. Nope, I think they were just general administrative questions. But we have one final poll that we'd like to ask you to participate in if you'll answer these final questions. Oh, and here's a question. What type of location data would you recommend be included in the metadata to maximize data discoverability? Lat long, state, county, is that enough, or is it important to include more than that? For example, like the HUC 12. And I'll let any of the panelists answer that question as folks are filling out the poll.
So in terms of the GeoConnects stuff and schema.org stuff, the more the better. At least latitude and longitude if possible for point data, because at least if that's specified in a machine readable way, it can be indexed. It can be indexed to the other things. But for some data sets, right, where you're talking about summary statistics over some sort of larger area, then something like a HUC 12 or a county or whatever level that data is aggregated to would be more appropriate.
We also have a question in the Q&A, Kyle. It says, can you please review how GeoConnects is currently accessing data from CUAHSI's hydrologic info services?
Sure. Is that question from Jared?
Someone else, believe it or not.
So the way it works is CUAHSI's hydro. So when I can share my screen again.
Okay, I will stop sharing and let you do that.
So share. So in data.cuahsi.org, right? So to get your data in here, the main way, right, would be to set up that ODM2 data system that has a web service that CUAHSI harvests from. And then you see all the points data. And so that's all the harvested metadata from those systems. CUAHSI then publishes from that data, dynamically creates a landing page like this for each site with time series data. And it generates the schema.org JSON LD markup, which I showed here automatically from that data. Or at least as CUAHSI modernizes the system, it will be automated further. Right now, I think some other scripts are run to create these landing pages. Then, because these sites have in this metadata the ID that begins with geoconnects.us, which they have minted by minting them at our identifier repository, which is managed through GitHub. So if you go to the GitHub of Internet of Water /geoconnects.us, if you click through namespaces, these are all the organizations or data systems that have minted identifiers with us, and CUAHSI is among them. So then we have the list of all GeoConnect's identifiers and their targets. So then we'll have a web crawler that goes to every single one of these pages. So it goes from this identifier to this website, which will look like this, and then harvest this metadata. So that's how that would work.
Great, thanks. We have a few minutes left in the workshop if there are any other questions.
Kyle, I have a question as we wait for other questions here. I might have heard Peter Callahan, the executive director of the Internet of Water, saying that in answering a question about like when the Google for water data is going to happen or like going to become a reality, I think he said 20 years. Is that right? I mean, it's real. It's good to be realistic, but I thought that, we should be doing that faster. What do you think? I mean,
oh, I'll put it this way. We hope to have an operational and scalable crawler. Sorry, a scalable and operating crawler, up and running by this time next year. And then it's really more of a social process of kind of recruiting as much participation as possible, because the thing about linked data is it's a classic public good issue. It's a linked data system is more useful the more people are participating and the more data is linked. So we know in a year that all of USGS systems, so NWIS, all of NWIS, all of CUAHSI, all of WADE, hopefully, we've talked with the Bureau of Reclamation folks at RISE, so hopefully them. So we'll have a lot of key players involved. We're also working with the Water Data Collaborative, which is sort of a collaborative group among community science organizations, and we'll hope to have them in this system as well. So that will be a core group, and that will be accessible in about a year in a sort of a quick way, and hopefully with a nice user interface. After that, getting every county's like stream gauge data in, that might be a 20-year exercise, but the infrastructure will be there.
Yeah, I mean, that's very exciting. I recall now that I think with Peter and even we were like discussing early on that for the public to really use this without even thinking of the underlying infrastructure, it's like you're by a river and you asked how much water is flowing there, right? Like, I mean, you don't know as an average citizen, like what even USGS is, some folks, or what CUAHSI is, right? So it would just tell them, oh, it's flowing at, I don't know, 100 CFS, right? Or I think what Peter suggested is like, if you ask a question, can I swim in this lake or not? And it would just literally tell you, I mean, it comes from EPA. But there are a lot of exciting opportunities or use cases, if you will.
Yeah, and part of, yes, and we would like that to happen. We would like to have, just like you can Google the population of your city and it just pulls it from the census and gives you a line graph. We would like that to happen for stream flow or for some water quality parameter. And that's why we're using the same technology that drives that, which is the schema.org markup embedded in landing pages. That is what allows Google to do that automatically.
Very exciting. Yeah, I'm really excited. I don't know, in the next 5, 10, 20 years, yeah, this will revolutionize the whole water informatics. So good job.
So Lily has posted for everyone links to join the peer-to-peer network, and we hope you'll consider doing so. And also the link to follow up with any questions to our panelists on the peer-to-peer forum. And I just wanted to offer to give the panelists any final words, Kyle, Jared, Otto, or Ryan, before we sign off for today. And thank you all for participating. Jared, I see you're off mute.
I was just trying to think what to say, Ashley, but I want to thank you and Lily for organizing this and making it run so smoothly, and for the participants for hanging in there with us. So thank you all for that.
Thanks so much. Okay, well, we hope that you all will consider joining us for our next peer-to-peer webinar, which is on December 9th, which talks more about the peer-to-peer network itself, with a panel of folks from Texas, New Mexico, and California talking about how sharing their information with their peers in other states have helped them in their journey to a modernized water data infrastructure. Thank you all very much. I hope you have a great afternoon or evening, and we hope to see you on the next webinar.